All right, so we want to determine how big does your sample have to be to get the margin of error that we're looking for. How many people do I need to talk to? So let's write it down. And I'm going to have you solve for n one time, and then we'll write it down so we know what n equals, right? So what are you going to do to get this n out by itself? We should divide by z, right? Let's divide both sides by z. So now I've got margin of error over z equals the square root of p hat q hat over n. Now, how do I get rid of the square root? Square both sides, right? That will take off the square root. And don't worry, you don't have to do this by yourself, but I think if you follow along, you'll understand n a little bit better. So this basically says the margin of error squared over z squared. Now you can leave it like one thing squared, doesn't matter, equals p hat q hat over n. Now how do you solve for n? What do we do? And multiply both sides by n. That way they're gone. And I have n times me squared over z squared equals p hat q hat. Now, how do I get n by itself? How do we get rid of that margin of error over z squared? Yeah, we'll multiply by z squared over me squared, right? And then now that's gone, and we have a nice formula, n equals p hat q hat times z squared over me squared, right? I, of course, don't want to do this every day, so let's add it to your brain. So go write that on your brain. And what does n stand for? Yeah, sample size, right? So go add that to your paper brain. Yep. Why is what? It's p hat q hat. We want, this is sample size, not population. So right now, add that to your formula. Okay, so make sure you have all of these. Remember your formula for confidence interval. The z part, this part is your margin of error. If we have p hat plus or minus, then we get a confidence interval. Make sure you got one sheet that explains it all, and this tells us how many people we need in our sample. So add that on, right? Everyone should have a nice paper brain. Yes, sir. What?
On your other sheet, you didn't square one of the terms.
What didn't I square? Yeah, me squared. The me stands for margin of error. It's not an e. No, that refers to margin of error. Okay. So now we have a way to figure out how many people do I need to talk to. Now, what if we don't know what p hat is? We can still do problems even if they don't tell us what p hat is, right? So I'm going to have you try something, and I'm going to have you tell me what you think we're going to use for p hat if p hat's unknown. So let's do p hat times q hat and get an answer. Let's say I gave you a p of 0.1. I'm going to have you type these in and try them. And it's going to become apparent which one we're going to use as we go through these. Now, if you know P hat, do you know Q hat? Yes, so that'd be, right? So put those in. You really don't need a calculator, right? And show this on your notes so you'll remember why we do what we do. Looking at the whole list, you'll be like, I get it. If P hat is 0.1 and Q is 0.9, what is P times Q? 0.09, right? What is 8 times 2? 16. So if there's a decimal, just move it over twice. 3 times 7. You only need this on your notes right now. You don't need the whole thing. We're only going to add one piece to our brain in a second, but we're figuring out what we want to do. Now remember where this goes. It goes into this formula. Now let me ask you a question. If you were a bit unsure as to how many people you were supposed to talk to, how many people needed to be in your sample size, would you be better off to have a few extra or a few too few? A few extra would be better, right? If I really need 20 people, I'd be better off to ask 22 than 18. So if you don't know P hat, they didn't give it to you, and you still want to estimate how many people should you survey, which of these do you think is the best answer for P hat? Which one's going to give you the biggest sample? Yes. See how that gives you the biggest number? And if you put this number here, you're going to get the biggest sample size. So if we don't know what P hat is, we use 0.5 for P hat. If we use 0.5 for P hat, then what is P hat times Q hat? 0.25. Now I would want this part on my brain. This is not relevant except to show you why we want the 0.5. Okay, but that's a standard. If you look it up in a stats book, it's going to tell you to do that. So let's add this to your brain. If P hat is unknown, use 0.5. Therefore, P hat Q hat is 0.25. It's kind of nice to know that, and you don't have to type in so much, right? Again, this is if P hat is unknown. Yes, sir?
Are you recording this lesson?
Yes.
Can I tell my uncle to drop him off at his work? Because we only have one car, so he picks me up from school.
You'll need to log out through the office then. You'll lose your attendance credit for today, but that's up to you. If you leave before 12:45, you lose your attendance for the day. Yeah. Okay. So did everybody add this to your brain? So I want you to look at your brain right now. Take a second. I'm going to pause this. Okay. So they want to know the 95% confidence interval. They did not tell me P hat. So I used 0.5 and 0.5. Now, per my formula, I need Z squared. So I'm going to look up Z. 95%, Z is 1.96. Over the margin of error squared. What's the margin of error? Margin of error equals 4%. How do I convert 4% to a decimal? So plug that in. There's one thing we need to learn. Tell me what the decimal is. I realize we're not going to use a decimal because these are people. We do not get parts of people. So make sure that you get 600.25. Once everyone gets that, let's talk about what we're going to use as our answer. Did everyone get 600.25? So what answer do you think you should record for how many people? We would say we think we want to record 600 because 0.25 is less than 0.5. Not true in this case. The ruling is when we're looking for n, if it's got anything over here, we go up. So we're going to say 601. So put a star. Always, this is one of your questions on your homework. Always round up to next integer. What? Yes, when it comes to how many people on n, when we're looking for the number of people we need to interview, we're always going to go up. Again, we don't want to underestimate. We're going to do a few problems together, which are going to help you see what happens when the population goes up and down. There's some big changes. It's really kind of, this problem we're going to do together is really fun. I'm not lying. Okay, is everybody okay with this? And does everyone have your brain filled out? Okay. I see people writing, so let me give you a minute. Then we're going to look at a real life problem and what does our data say? All right, let's read this together. I would have you guys read, but then people at home can't hear, so I have to read it. Y'all have heard of No Child Left Behind, right? It's an act from the Bush administration to try to make sure our schools aren't failing the children and we're not leaving children left behind. Can't read and write. So let's look at, this is a really good thing for us to investigate all these different numbers and what happens to what we read. So the No Child Left Behind Act mandated a school testing program in reading and math and minimal standards. But legislation left it up to the states to develop the testing program and the minimum performance level. Many states had already begun to process to establish statewide testing programs and performance standards. But while some states set absolute benchmarks, either the school meets or exceeds the minimum standard or it doesn't, other schools took another tack. The idea of using confidence intervals is not an isolated practice. When this application was written, 35 of 50 states use the confidence interval approach to interpret test scores. So here's what's happening. We want to know if our schools are helping kids, right? Y'all are used to taking the STAR test. Here we have the STAR. Before that, we had TAKS and TOS, and we just keep changing the name. It's still the same thing, right? So we take a test and we say, okay, Susie, you didn't pass the test. You don't know your math. You have to retake this class, or you have to retake this test. We want to know that kids are okay. In 2002, so y'all were not even born, right? Maybe you were babies. The Bush administration sponsored legislation known as the No Child Left Behind Act. It attempted to improve education by mandating a testing program and minimum standard. The act left it up to each state to develop a statewide testing program in reading and math and a minimum proficiency level. So at this point, every state has to have a state test, and they have to say, Blake can read, Blake can't read. Travis knows his math, or Travis doesn't know his math. We now have a test. Schools that did not meet the performance level were classified as failing schools. Now that's harsh, right? No school wants to be classified as a failing school. Schools at these students at these schools would be able to transfer to other supposedly better schools. Many states establish 40% as the passing rate. So if you get a 40 on your test, you're okay. Principals and school system administrators do not want their schools to be declared as failing. So many states have adopted a controversial procedure to buy some wiggle room on test results. Let's think about this for a second. This is a real problem. It's still going on. We're still testing. What's the big deal if your school gets classified as failing? What happens? Funding. Now let's talk about this. This is a big deal. Students at these schools could be able to transfer to other supposedly better schools. Is that good? Well, let's think about us. We do well, right? Our scores are very high. Are classrooms crowded? If everyone were here, I have 30 kids in all my classes. Do we have room to take in other people from a failing? We don't. This gets very controversial and expensive. For one thing, we're already full. For another thing, how much money does it cost to start busing students? And then what happens to the school that's failing? They lose funding, and does that help you? If you're failing and you lose funding, do you do better? That gets real tough, right? This is very scary to schools. We kind of don't get it because we're not in that situation. But if you were in that situation, it's a very scary thing going on. It's like, don't get classified as failing. So here's what schools wanted to do. Instead of considering test results for 1 year to be the entire population of interest, they argue that test results should be viewed as a sample of school performance from a population over multiple years. Kind of like that way, if you just fail 1 year, you're still not failing, right? Each year's results come from a sample of students gathered at one point in time, they say. Consequently, it makes sense to construct confidence intervals for the population passing rate. At this writing, so when this problem was written, 35 states use a confidence interval approach. We're going to look at that, dive in, and see if you think it's a good practice after we look at numbers. Critics argue that using the confidence interval approach to determine which schools pass distorts the truth. For example, a small high school in Oregon met the state requirement of 40% pass rate on a state reading test, even though only 28% passed the test that year. In Maryland, an elementary school, I'll put them a different pink. In Maryland, an elementary school met the state's standards, even though 31% passed and 41.5 was the pass rate. Now, this sounds really crazy to us because we have, what, a 99% pass rate? So let's think. You only have to pass 40%. You get a 40 on the test, you pass. So only 28% of the kids pass the test. How is it possible that they're saying that they're okay? Let's look. The Oregon school tested 50 students and 28% passed. What variable does this give you? Which one of our variables is it if we took a sample of 50 students and we got a 28% pass rate? That's P what? P hat. Why is it P hat and not P? Because it's a sample. So P hat equals 0.28. Right? P hat equals 0.28. If P hat is 0.28, let's go ahead and figure out what Q hat is. What's Q hat? Subtract that from 1. Think about $1 minus 28 cents, and that gives you 72. Is everybody okay with where P hat and Q hat come from? And I'm a little worried that some people aren't writing anything down. They're playing on their phone. If you aren't participating, I'm probably going to ask you to just leave. It's ridiculous. Take charge of your school. Take your notes. participate in your education. All right, calculate the resulting 95% confidence interval. So take your brain out and look at what a confidence interval is. And let's write that down. P hat 0.28, right? Plus or minus Z. 95% means I use 1.96 times P hat Q hat all over N. How many kids did we talk to? 50. So y'all take a minute, punch that into your calculator. Remember, if you punch it in one time, you'll do a plus sign. Then you go up and highlight it and hit enter. It pulls it back down. Then you can change the plus to a minus and you don't have to retype all that. So go find these decimals and you tell me if you get what I got. Please do it yourself. I need to help you if you have any calculator troubles, so that when the test day rolls around, you're not stuck. We do have a test over this. It's really not a multiple choice test. You're going to have to type in nut decimals, so you better know how to find them, right? Always 4 decimals when you have confidence intervals. And I don't want to sound cranky, but we're getting towards the end, and I know the senioritis spring fever is getting us. So I'm going to try to pull you in and keep you with me. Y'all have excellent work, and I don't want it to go down. Yes, ma'am.
I know how you highlighted that. How do you change the symbol without erasing the whole thing?
Arrow over. Use your arrow key to scoot over and highlight the symbol. So if you have something in your calculator, let's say I wanted to copy that, you just go up and highlight it and hit enter, and it brings it down, and then you can scroll through and change whatever part you want. Did that make sense? Y'all got to stay with me. So see on this one where I have some numbers typed in, I enter that, and now I can go through and change any part of that that I want to change. See if you get what I get. This is your calculator test. And everyone knows how to put a fraction in, right? Alpha y equals 1 to get a fraction. You know where the square root is, right? What does this confidence interval mean? That means between 15.55% and 40.45% is a passing rate. Right? So, how can we say that if you scored a 28%, you're passing? Because with our confidence interval, anything between 15 and 40.45 is passing. Is 28 in there? So if 28's in there, we can say they passed. What do you think about that? You think that's good? Yeah, that's way too big, right? You might as well just, do you find these numbers very useful? Not very good, is it? I don't like this. Explain why the school could be considered to have met Oregon's requirement. We would say something like 40% lies within but 40% is the passing. So 40% lies within what we got from a 28, is what we're saying. 40% lies within the 95% confidence interval. Therefore, it meets the requirement. And I want to go over what you just asked because I see where you're coming from. Okay. 28 was our p hat, right? 28% was our p hat. So we used the given p hat, 28%, to write our interval. When we get our interval, as long as it covers the required 40%, we're good to go. And this 40% fell within our boundary, so we're okay. This is really good for the administrators of that school, right? Because they're like, woohoo, no one can read, but we're gonna get a good grade. How do you feel? Do you think this is good? Do you think you should use higher, like 99%, or do you think you should use lower, or do you think you should use more kids? I don't find this very good. Everybody's going to pass. You can go all the way down to 15%. No, that's not good. So let's try some more stuff with these same numbers. What if they tested more kids? Would that tighten things up? Would things look better or worse? Let's see, because we really don't know. We haven't investigated this yet, right? So do that same thing. You can go copy and paste. But what are we going to change into? Yes, go copy and paste. You don't have to retype it. And let's try in. Everything else will stay the same. You think more kids is going to make it better? Will it widen or narrow our confidence interval? Let's check it out and see. Let's really type it in. So make sure you get it, really copy and paste, use your calculator. So increasing the population, what did that do? So let's do this. N increases, narrows interval. Do you think that's a big key concept you might want to know? Maybe you should add that to your brain. N increasing narrows interval. I think I'd want to know that, right? So if we increase N, it narrows our interval. Do you think a more narrow interval is good or bad? Well, it might give us a better idea. Is it good for the school that's failing? Is it good for the principal? Not good for the principal, right? Because what happens now? Now, with a sample of 75, the school does not. The state requirement. Now we're failing. %40 is not in this interval. Right? We're now only go up to 38. So this is 0.28. I'd have to get a better number there, right? I need a better number than 28 now. I'm going to have to get more kids to pass. So do you think it's important that our sample size is bigger? Yeah, right? Here's another idea. The school could use a 99% confidence interval instead of 95. Now, before you do the math, you're just going to cut and paste and you're going to change the 1.96 to 2.58. But before you do it, I want you to think about what you think is going to happen. If we go up to a 99% confidence interval, is that going to widen or narrow our interval? All right, plug it in and check.
Is it still 50 students?
No, we're using the 75. We're going from this one right here. But look at that interval and tell me about it. So increasing level widens. I'm going to put that down. I'm going to write that on my list. Increasing widens. I might want to kind of keep that key concept in, that as I go up this ladder, it gives me a wider interval. What does a wider interval do? Gives me more wiggle room, right? Who wants more wiggle room? The administrators, the people in charge of this district, it's not going well. They want it wider. Now, does it pass now? So now let's think about this. If you're not a statistics person, you never took this class, if you were a parent and you didn't understand statistics, what sounds better to you, 95 or 99? 99 kind of sounds better, doesn't it? But if you understand the numbers behind it and what that means, what does that mean actually? It means you get more wiggle room. It's not so good, right? Okay. Level widens. So now what? Passing. You all can write a sentence. I'm just going to write it down real quick. So now we're meeting the state requirement again. Yep. The interval. These numbers get further apart because think about this formula. This is as your confidence interval goes up, this number gets bigger. So you're saying I can go up higher and down lower. You're increasing your boundaries. We're basically going to let anybody in, right? All scores are good. Now at the 99% level, how many students would we need to, we should really sample. How many would we need to pull in the sample to be within? So what N do we need? Right? We're still back with our 28% pass rate, but now how many students can I sample? I sampled 75. How many students could I sample and still get up and pass? Your margin of error. Oh, let's talk about that. Yes. This is where I wanted to talk to you about this margin of error. Now, what is the pass rate set by the state? What's the accepted? What am I supposed to have? 40%. Right? What did I get? What pass rate did we get in this example? 28. So how much wiggle room do I need? What's 48 minus 28? right? So if I'm supposed to get 40 and I got 28, I need a margin of error of 12 points because the margin of error says you could be this far above or this far below, right? Does that word margin of error make sense? So that's where the point 12 came from. And I would add that to my list. Margin of error I need is the accepted minus what I have. Think about that as your wiggle room. If I said, I'm just going to give out A, B, C, or D on this test, and to get an A, you have to make a 90 plus or minus 2. That means you either need a 92 or an 88, right? It's your wiggle room. Margin of error says how much above, how much below. So your answer is in the middle and you can be above or below that, right? It's your wiggle room. How many kids can we test and still be okay? 94 kids. So now what do you think about all this? Can I pretty much manipulate with these? Yeah. Do you think a confidence interval approach is a good thing to determine whether your school's doing okay? Well, the states do. The states choose. Do you like this system? I don't think I like this system because we can really be substandard and still fall in the line, right? We're not doing a service to our students if we let this happen, right? If this is happening, we need to fix that. We don't want to have kids graduate from high school and they don't have the skills they need to survive in the world. You need to go to college or technical school. You've got to be trained to do something, right? And if I let you out of here and you go to college and you say, well, I don't know what 4 + 6 is. And they're like, what? Right? Now, this is hard for us to imagine because y'all are overachievers. Y'all succeed very well. All right, let me have you try one on your own. Well, let's talk about it. Show how it's possible. Let's say you're the principal for a Maryland elementary school to meet the state 41.5 requirement, even though 31% of the school students passed the state math test that year. Show how many students can be tested to be within the 95% confidence interval and within the 99. Well, let's write our numbers down, right? So what is P hat in this problem? 0.31. So what is Q hat? 0.69. All right. And what is Z for the 95? 1.96. We're going to try it with that one. We're also going to do 99. What's the Z for 99? 2.58, right? Do I need any other numbers? I need a margin of error. What's my margin of error? They want me to be 41.5, but I'm only at 31. So what size margin of error do I need? Does that sound bad to you? That's pretty high, isn't a margin of error of 10%? But there's all your numbers. So you use your formula and you plug it in and you figure out how many kids we need to test. This is your little, we're almost done.
Ms. Coughlin.
Yes, sir.
On number 6, how did we get 94? I plugged in the 0.268 or 0.286 times the squared number that we have.
Yes.
Is that not how you get
That right
94?
in. We plug this right in.
Okay, I got 134.
Okay. Let me see. Whoops. Did y'all get 94? Okay. Let me see what happened. Right? Parentheses.
Oh, never mind. I thought that parentheses on the left was a 6. It looked like 6. Not 0.72. Never mind.
Oh, you thought this was 0.86? No, it's parentheses.
Yeah.
There we go. And you know, I haven't looked up Texas. So let's look up Texas and see if we use this system. Look that up on Google. I don't know. Okay, what'd y'all get for N? See if you got really punch it in. Number 8 is a question that you can answer. What do you think is the most compelling reason for or against this practice? This is a good test question, and I may refer back to that on the test and say the example we did in school. What'd you think about that? What do you think about the confidence intervals? Do you like that? I'm not sure I like that for schools. We can't be leaving anybody behind like that. Do you think kids that get a 31% pass rate when the state is requiring 41.5, you think that's okay to let them slide? I'm not sure I like that. And one thing I want to mention to y'all about margin of error, because there's some questions on your homework. If I said, I'm going to give you, for example, is everyone done with these? Did you get the numbers? Okay. So if I told you a confidence interval goes, I gave you an interval 40 to 50, what would the margin, I want to see if you understand margin of error. What would the margin of error for that be? Remember, margin of error is plus or minus some points. So if the margin, if this is 40 to 50, what's the center number? 45. So what's your margin of error? 5, because you add 5 to get 50, you subtract 5 to get 40. So the distance between here divided by 2 also gives you your margin of error, right? Does that make sense? Not if you have your confidence interval, you can see it because I've already figured it out. Does that make sense? And there's one other thing I want to point out before you do your homework. In Delta Math, when they ask you your questions on, you'll recognize the problems that I wrote and then the ones that are standard Delta Math questions. Let me show you this. I want to show you what they did and it bugs me, but I wanted to use the questions, so they're there. On these questions right here where it says margin of error, and I make sure you notice this so you don't get them wrong. Whoops. You have a little homework. These are ones that I wrote. They continue on with yesterday's homework. That's why they start with 6. These are ones that are in there. On the ones that say margin of error for proportions. What's the margin of error for 95%? It's 1.96, right? In Delta Math, they rounded that up to a 2. They rounded 1.96 to a 2. So when you use 95%, you're going to need to use 2. Why did they do that? Let me show you what their thinking is. They're not wrong. They're just kind of, eh. When I show you guys, right? If I show you guys the empirical rule, if I have my mu and I go 1, 2 standard deviations above or below the mean, what percent is 2 standard deviations? 95%. So when the elementary way, if you were just a beginning student, we're going to use a 2 for that 95%. Now we know for problems I write, 95, we're going down more technical to the 1.96. But that second section in Math Lab, they rounded this up to a 2. If you forget, I'll fix it. I just wanted you to notice that. Okay. All right, so you have a little bit of homework. It's actually not homework, it is do now work. Ooh, I'm gonna call it the do nows.